Hello there, today we're going to look at the factor theorem. This is something we come back to actually in year 13, but for now we're going to try just to get our heads around it. It's a posh method for factorising more complicated expressions than we would have seen at GCSE. So for instance, we might be asked, and we are asked quite a lot, to factorise cubics. Cubics of course have the highest power is x cubed. And we could also be asked to factorise quadratics. Obviously, I actually meant to write the next one. Obviously, quadratics are x squared. I might as well write it up now here. As we go up the powers, the next one would be a quartic. That would be an x to the 4 one. And you do see these, but the main one is certainly the cubic. So a couple of questions just to warm up on this. X squared plus x minus 12. I want two brackets. And then it says, interestingly, solve the equation x squared plus x minus 12. So you can just do those two. And there's two more here as well, which you will need to do as well. By the way, this number 2, this is the bits that say x equals something and x equals something else. And of course, these come about because now you'll notice it says equals 0. I've made it an equation and solved an equation just to find those. Then try and do 3 and 4. Pause the video and I'll come back and give you the answer. Okay, so I'm going to go through this. Hopefully you've done them now and you're good at them. So if I was doing this, I'd be looking here, numbers that go into it which make 12. But because it's a minus, I want a difference of the 1x. So I'm thinking to myself x plus 4 and x minus 3. You can see they make 12 when they multiply them together, and they have a difference of 1. On that basis, you're meant to switch the signs. You should remember that becomes x equals minus 4. Because it's a minus 3, it becomes a plus 3 here. You don't usually write the plus, you just usually write the 3 on its own. Second one, if you've done these, you should just be looking at it thinking, God, that sounds hard. You know, write it as the product with linear factors. Well, it's the same thing. All I want is a double bracket. I've hopefully done that. And this next one, by the way, it says find the roots of the equation. Look, again, it sounds really hard. Really, they just mean solve the equation. They just word it differently. So anyway, when I did this, I thought x plus 10, x plus 1. Notice now it says plus at the end, so I'm adding them to get 11x. And therefore my answer should be x equals minus 10 and x equals minus 1. So hopefully that's what I've got. Yes, I did. The factor theorem then, this is what we're going to be using quite a lot. If we divide a number and get a remainder of 0, we automatically know two factors of the original number. So for instance, I've given you 256. I know that if I divide it by 8, I get 32. And notice it's 32, remainder 0. And because it's an exact answer, I can say that 8 and 32 are factors of 256. So look out for these remainder zeros. You kind of saw these a lot at primary schools, but after that they kind of become less important, and now suddenly on algebra become important again. So with algebra, notice this, I'm telling you that x cubed plus 2x squared minus 5x minus 6. If I divide that by x plus 1, I get this. Now, who would want to do that? But that, I'm telling you, is the answer. And based on that, I can say that I have a linear factor. The linear factor is the x plus 1. You'll notice I divided by x plus 1, so that is a factor. I'm describing it as a linear factor. Those were the 8 and 32. I didn't distinguish between them. I did the division. That was a factor, but also my answer is a factor. 8 and 32 are factors of 256. But here I can distinguish between them because I've divided by x plus 1. Yes, I have. It is a factor. I'm saying it's a linear factor. You might be thinking, why? Well, x squared plus x minus 6. The other thing, this is a quadratic factor, simply because it's got an x squared in it. That's all I'm saying. Anyway, in general, we're looking for remainders of 0, of course. And here's the weird thing, and this is called the factor theorem. If I am dividing by x minus a, and it is a factor of f of x, it's the same thing as saying that f of a is 0. Now, this is not obvious. This is not obvious. So really what I'm saying is, say I have some function f of x. I don't know what it is, x cubed minus 8x plus 3. No, I'll say 3x squared plus 3x minus 5. So I've made that up totally. But let's just pick a number. Now, if I get, when I put my number in, an answer of 0, I found a factor. I bet I won't because I've made this up. So 8, x cubed is 2 cubed is 8. And I've said minus 8 times the 2 squared plus 3 times 2, which is 6, take away 5. That's my function that I've made up. Well, I already don't think that is equal to 0. 8 take away, this is 32 if you do it, plus 6 minus 5. That's the equivalent of minus 23. This is not equal to 0. And therefore, it's not. That doesn't tell me anything about a factor. I need the answer to be 0. So just bear that in mind. Notice there's this other case, which I'm going to do. And this basically says, what if I put a fraction in? Well, if I put a fraction in and I get 0 as an answer, then this too tells me something about a factor, but it's a more complicated factor. Now it's ax minus b. Let's do an example. I'm saying to you here, I've made up a different function, x cubed. You can see it's broadly the same as I made up here. X cubed plus 2x squared minus 5x minus 6. Use the factor theorem to show that this is a factor. Well, that's the other way around, totally. It doesn't tell me to put a number in and say, what do you get? It says, I want to show that this x plus 1 is a factor. So notice over here, when I showed that x minus a was a factor, I put a into the function. And you see how the sign has changed. So over here, if I need to show that x plus 1 is a factor, I need to change the sign. So I'm going to put minus 1 in, and you always change the sign. So I got x plus 1, I put minus 1 in. So let's put minus 1 in. I get minus 1 cubed plus 2 lots of minus 1 squared minus 5 lots of minus 1 minus 6. And you can do this on a calculator if you prefer. I'm going to do it in my head. That's minus 1, then it's plus a 2, then it's plus a 5, minus a 6. And what's that? Minus a, that's 0. Perfect. Therefore, x plus 1 is a factor. Is a factor. It's a linear factor if I wanted it, but didn't care about that. Of f of x. That's the posh way of writing. F of minus 1 is 0. Yep, we got that. So x plus 1 is a factor of f of x. So here we go. Show that x minus 3 is a factor of this. Okay, then this should be easy now. I'm just going to pretend that this is f of x. F of x equals this lot. And therefore, what number do I put in? Well, it says x minus 3, so I have to change the sign. 3. I think last time I had I can't remember what I had last time. Last time it said plus 1, so I put minus 1 in. Yeah. This time it says minus 3, so I put plus 3 in. Change the sign. So anyway, it's 2 times by 3 cubed. Notice all I'm doing is I'm substituting it into this thing. Minus 5 times by 3 squared. Minus the 3 minus the 6. Let's work that out. So if I work this out, I get, well, I know 3 cubed is 27, 2 27s are 54, so that's easy enough. 3 squared is 9, 5 9s are 45. And minus 3 minus 6 is minus another 9. Oh, that is definitely, if you do that, it's definitely 0. So now I've got the 0, therefore x minus 3 is a factor. Now, this is now the new bit that we're going to do, is a factor of f of x. So now I have to find the other factors. And to do that, we have to use long division. I think we saw long division quite recently. So here goes. I'm going to do x minus 3. I'm going to divide it into 2x cubed minus 5x squared minus x minus 6. So yeah, we saw this long division in the last PowerPoint, so should be fairly close in your mind. So what do we do to the x to get 2x cubed? And you should be saying to yourself, oh, I times it by 2x squared. 2x squared times x gives me 2x cubed, that's why we did it. 2x squared times minus 3 is minus 6x squared, and put it in the bracket to remind you to take away. So that take away, that disappears. Minus 5x squared minus the minus 6x squared, that's like a plus, so that's plus x squared. Bring down the minus 6. X minus 3, what do I do? Oh, I times that by plus x. X times ax is x squared. X times the 3 is, well, minus 3x. Put it in a bracket to remind me to take away. And that disappears. X minus plus, so that's like 2x. bring down the minus 6. And this, I reckon, is to plus 2x's. Take away 6, yes, it did work. I've got 0, which is what I want. But this tells me then that f of x is equal to the x minus 3 that I had, and that I was dividing by, times by this quadratic factor. And this quadratic, oh, it's 2x squared plus x plus 2. And this quadratic factor, you might be able to factorize more, but it doesn't look to me as if that's one that factorizes. I think that's the answer. Yes, it is. Look at that. You end up with a quadratic factor at the end. Sometimes this quadratic factor factorizes again. Sometimes it doesn't. This time it didn't. So here's another one. Show that this is a factor of this. Well, again, this was one of the fractional ones that I said. I said if you have f of a over b, or actually I said b over a, I should write it the same way down as I did before. If that equals 0, then we know that, notice the way I'm going to write this now, the a at the front, ax plus b. In fact, it says plus here, so I better change the sign. You always have to change the sign. Is a factor. So bear that in mind. It wants me to prove that 2x minus 1 is, so the number I put in, going backwards here, well, I put the number at the front, ax, on the bottom, so that effectively that's on the bottom, 1's on the top. It says minus, I changed the sign so it should be a plus. So this should be 2 lots of a half cubed, minus 5 lots of a half squared, minus 14 times a half plus 8. I'm going to type that into my calculator, I might as well. 2 times a half cubed minus 5 times by a half squared, but make sure you put the brackets, minus 14 times a half plus the 8. And it says 0 with a bonus, because that's what I wanted it to say. So I get 0, therefore 2x minus 1 is a factor. Okay, so we've done the first job. It now says use long division, so I'm going to do that down here, because otherwise I'm going to run out of room. 2x minus 1, I'm not sure if I've even got time to do all this, but I shall do my best. So what was it was 2x cubed, it's not a very straight line, was it? 5x squared minus 14x, let's try and bend that back round again, plus 8. So 2x times by x squared gives me 2x cubed minus x squared. Then I'll put it in a bracket to remind me to take it away. It's minus 5 plus, I think it's minus 4x squared. Bring down the 14x. 2x times by minus 2x gives me a minus 4x squared when I multiply, plus 2x. Put it in a bracket to remind me to take it away. Dead easy to make this 12, but minus 14 minus a 2 is minus 16x plus the 8. And I reckon that is times by minus 8, which gives me minus 16x plus 8, which is of course 0. So I have found my quadratic factor. It's x squared minus 2x minus 8. Hence fully factorize this. Well, I already know then that 2x minus 1 goes into it. The thing that I just got, this quadratic factor, I write again, x squared minus 2x minus 8. But it does imply, when it says write the fully factorized version of this, I think this therefore factorizes. So if I just, you can do it in a calculator, or you can just see it. I reckon it's x plus 2 and x minus 4. Notice it doesn't say solve the equation, it just says factorize. So I think that's the answer. X plus 2, x minus 4, and the original 2x minus 1. Notice it doesn't matter which order you write them in. Now there's more to do on this. In fact, there's one more to do, which I'll do in class. You might have just seen it there, it's no problem with that. But in class I'll finish that off, and then in class we will do some questions. Okay, hope that makes sense.